Lesson 3, Deductive Reasoning. I can use the laws of logic to form a logical argument. Deductive reasoning. Use facts, definitions, accepted properties, and the laws of logic to form a logical argument. Now, if you're asking, Ms. Sidrick, what are the laws of logic? It's a great question. The laws of logic, we have two of them. The first one is the law of detachment, and the second one is the law of syllogism. And we are going to talk about them as we practice them. So first off, the law of detachment states, if the hypothesis of a true conditional statement is true, then the conclusion is also true. So our conditional statement is if two segments have the same length, then they are congruent. So that's our statement. So this is the statement we're going to use to determine if this is true. So you know that DC equals XY. So what first we need to do is we need to know, is the conditional statement true? Because in the law of detachment, we have to have a true conditional statement. So that conditional statement is your if-then statement. So that's this piece right here. So if two segments have the same length, then they are congruent. Yes, that is true by the definition of congruent. Congruent means that they have the same measure. So that's step one. Step two is identify the hypothesis and conclusion of your conditional statement, because both of those pieces are used. So we need to make sure we know the two pieces. Hypothesis is what comes after the if. So if two segments have the same length, our conclusion, then the segments are congruent. So the last thing we need to do is make a valid conclusion. So if we know that DC equals XY, is that true? So we have two segments have the same length. That's our hypothesis. Is that what we're claiming here, that two segments have the same length? Yes, that is what we're claiming. So that is true. So as long as our hypothesis is true, then we can claim the conclusion. We can claim that the segments are then congruent. So we just write out that segment DC is congruent to segment XY. So that's how we use the law of detachment. So one more example here. Use the law of detachment to make a valid conclusion. Mary goes to the movies every Friday and Saturday night. You know that today is Thursday. So, again, is the conditional statement true? Yes or no? Well, it's just a given fact. So Mary goes to the movies every Friday and Saturday night. So that's what we're given. That's what we're told. So yes, it is true. Identify the hypothesis and conclusion of the conditional statement. So if we rewrite that statement as an if-then statement, it would look like if it is a Friday or Saturday night, so that's going to be our hypothesis, then Mary will go to the movies. So that will be our conclusion. So then that last step is, what is a valid conclusion? Our hypothesis is today is Thursday. So we have to ask ourselves, is this true based on your hypothesis from your conditional statement? Our hypothesis says if it is a Friday or Saturday night. We are claiming that it is a Thursday, which means they don't match, which means that's going to be false. Now, if we look up at our law of detachment, nowhere in that law do we talk about a false hypothesis. We only know that we can claim the conclusion is true if the hypothesis is true. We have no case for if the hypothesis is false. It doesn't say if the hypothesis is false and the conclusion is false. So we have no information that we can correctly or logically say is true. So we would just write no valid conclusion because we can't make one. Because based on the facts, all we know is that if it is a Friday or Saturday night, Mary will go to the movies. Well, we don't know. She might go to the movies every other Thursday night. She might go to the movies on a Monday night. She might randomly decide to do it on a Sunday as well. We don't know if she will go to the movies or not on Thursday. What we do know is she will definitely go to the movies on Friday and Saturday. So sometimes we can't make a valid conclusion, and that is okay. All right, let's move on to the law of syllogism. So it's a lot of words, but there is a pattern. So if hypothesis P, then conclusion Q. Then if hypothesis Q, so this Q is becoming the hypothesis of this statement, so it's going to be the same piece, just rewritten in the if form, then conclusion R. So then what we can claim, this would be our valid conclusion, if hypothesis P, so we take it from up here, then conclusion R. So we've got this little crisscross thing going. So if these two are the same, then these two match up to be your conclusion. There is that little crisscross. So use the law of syllogism to make a valid conclusion. We have, if Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So first we want to find the crisscross pattern. You may have to rearrange, you may not. But if we look, we see that there is this crisscross right here where the conclusion of the first statement, Jesse will be Rick's lab partner, becomes the hypothesis of the next statement, Jesse is Rick's lab partner. So then what we can do is we can say that the valid conclusion would be putting these two pieces together right here. So we will rewrite the statement as if Rick takes chemistry this year, then Rick will get an A in chemistry. So that's how you use the law of syllogism. As long as there's that crisscross pattern, those two things will coincide. It's like following a logical chain of events. We have event number 1, we have event number 2, this is still event number 2, and then event number 3. So if event 1 and 2 and 3 happens, we can say then if event 1 happens, event 3 will happen. As long as that event 2 happens. So let's do another example. Use the law of syllogism to make a valid conclusion. If x squared is greater than 25, then x cubed is greater than 125. If x is greater than 5, then x squared is greater than 25. So first off, find that crisscross pattern. So in this case, the crisscross is in these two boxes, but we still have that crisscross. We still have that if here, and then it becomes the then here. So if you wanted, you could rewrite the two statements, flip them around so that it crisscrosses like it does in the law of syllogism. But it's fine, it's just written backwards. So we would read this as event 1, this would be event 2, and then this would be event 3. So we're still going to match up these two that are not the matches, and we'll write our valid conclusion. So what is our valid conclusion? Our valid conclusion would be if x is greater than 5, then x cubed is greater than 125. All right, one more example for you guys, and I just want you to try this on your own. So I'm going to give you the setup for you to fill in the blanks, and I just want you to try it. Just try it. If you have questions on it, email me, message me, pop into the Google Meet, but I want you to be able to give it a shot, give it a practice go. And then once you do that, you can go ahead and work on your practice.